Okay, this is TempleOS 5-minute random code walkthrough episode 83, and I'm your host, Terry Davis. And today we are in, oh, isn't that special? Okay, this is a optimization on text documents. This is an excellent place to start if we want to, this is an excellent teaching. Okay, so what we have is a utility that you give it a doc opt, you give it a file mask, and it sets the flag for recurse and text files only. Everyone needs to, one of the first things you have to get familiar with is, well, the find files routine. Find files. You have when you want to look for files that match a name in a directory, you give it flags. Usually, all the utilities that use this, you can give them flags for. +R is recurse. That means to send into the directories, all the subdirectories, and then all the subdirectories. Anyway. I have the ability to filter, to limit to just text files, source files, ahead of time, just in time, graphics files. Anyway, so what this does is this first sets flags, turns on the R and the T, and then it sets the flags based on the text that you when you do this file, the argument, you give it a text argument. So, for example, you might say at the command line, well, you might say doc opt, well, you're probably going to do it on all files, /*, comma, and then you give it options. You can turn off recurse, since that's turned on by default, and you can turn on just in time, something like that. Anyway, so then it calls this routine, and it passes. I wonder why I made a. Oh, that's why. Okay, so it passes a find files is find files gets the files in a mask, and so it makes a linked list. It returns a linked list of directory structures. So a directory entry has a link to the next one in the chain. It goes up to the parent if there is one, or it goes to subdirectories. So the way you traverse a linked list is you do a loop with. So this will traverse a linked list, and then as you're going, you traverse down. This is recursive, and you do the subdirectory, and then it's gonna, when it gets to this point, it's gonna jump in, and now it's into itself, and now it's doing the linked list again. So that's how you traverse a tree. Anyway, we delete the entry with that it. Find files gave us the entry, and we delete it here, and we get the next one ahead of time before we delete it, so that we you don't access it after you delete it. Anyway, now we process each directory. If it's an attribute directory, you don't process, you recurse. If it's a file, you call optimize file, and we're giving it returns a count of changes. I do believe that's the number of optimizes, and so this optimizes a file. Now in TempleOS, someone said in Unix everything's a file. In TempleOS everything's a document. The command line is a document that we're editing. Everything you see is pretty much a document. And so you need to learn this document format. It's a linked list, a circular linked list. And anyway, we read the whole document, and this gives us okay, we call optimize document, and we print the number that we, if we got some changes, then we write the document, then we delete the document. So here's how we traverse the document. We start at the root. I don't like the word head anyway. I call it the root. Most people would call it the head of a queue. I call it the root of a queue. Anyway, so it has a next and a last, and then we go in a circle around the queue, just like it's similar to how we went in the linked list, except with a queue, you search for the beginning. When you get to the beginning, again, that's the end. Anyway, so when you get back to the beginning, that's the end. It's a circle. So now we optimized a document entry. So the documents have, so the documents have a type for each entry. So where's the type? Okay, so you can have a text entry, you can have a new line, a soft new line. When you're doing word wrap, it distinguishes soft and hard new lines. When it saves the file, it saves the cursor position so that when you have an IDE, it'll pull up the file and put the cursor in the same spot it was saved. Anyway, a tab. If you do a clear entry, that will, I can show you what happens. I'm going to do $, you can't see this, but $CL $, and it clears it. So if it hits a clear entry, it clears it. That almost never happens. Page break. So we can hit control return is a page break. And anyway, page length. If you notice, it's 66 lines. If you do a page length, Control L will do will let you put, let's put page settings, let's put page length, let's set it to 20. Now if I say control carriage return, we're about 20 lines down, Anyway, left margin, right margin, footer, word wrap. So getting back to what our business is, we want to optimize entries. What are some of the optimizations we can do? If it's a link, then what we do is we check if it starts with FI. So one of the other things you have to learn to be a user of TempleOS is is it in here? The link types. FI is a file. FA is jump to an anchor in a file. Jump to a string. FF is jump to a string in a file. Jump to the second occurrence of a string in a file. Jump to a line number in a file. Now, if it's just a file name by itself, that's the same as a FI. So what we do here is we check for FI and get rid of the FI. If it's we see if we can get rid of FI. And down here we see if it has a .z, and we get rid of .z. And then when I'm doing this, when I'm doing this, I uncomment these and do some dangerous optimizations. Okay, so a link, Control T, LK has a tag and an auxiliary string. That's the link. So if this document entry has an auxiliary string, this is for entries besides links as well as links. And so this is kind of dangerous. We get rid of the .z because as a matter of fact, our file system will search when you try to read a file. It tries to find whatever file name, and then if it doesn't find it, it checks for the same thing with a .z. Or anyway, so if it has a .z in the tag, so this is just basically all I'm doing with my optimizing is getting rid of FI when it's just a file name by itself, and I'm getting rid of some of the .z's. But conceivably, we might have more optimizations down the road, and when they get put in there, you would benefit. If you see what I do when I distribute my actually, I don't think I do that. Do it? Maybe I do. When I make a distribution, you know what? I don't think I do that. Let me look for doc opt. Okay. Well, that answers that. I sometimes, okay, well, anyway, so I don't do that. I don't do it every distribution, but once in a while I optimize. So that's that. Now what I should show you is, why don't we show you, that's lovely. Anyway, why don't I show you, let's see if we got, how we doing on time, 11 minutes. Okay, so cdoc entry star de that's not what I want to do. Let's do cdir entry. That's what I meant. Star de temp. I always use the same files find. How about slash atom slash star cpp star, that'll work. And then I say we can say plus r, and now what I do is de1, and then what I do is I go through my list and then when I get done, I say dir tree delete. Okay, so I hope it doesn't crash and ruin my video. So this will, I'm going to hit F5, and it didn't do anything. We got an FUF exception. Oh, you know what? That's kind of fortunate. Oh, dang, we almost screwed up. I tried to pass it a text. It's looking for a binary flag. I almost crashed my video. Okay, FUF recurse. And you know what we do? We pass it FUF just files. If you say just files, it flattens the tree. So nothing. What happened? Oh, no. Oh, no. What? Let's do this. Oh, they're all .z's. That's what it is. Okay, atom slash star cpp.z. Okay, boy, I was getting worried. I got a little bit lucky. Okay, so you can see it recursed into subdirectories, and it we got all the files. So we can just play with this. Let's say no file. Okay, let's see. You see this utils? No, how about you see, let's say no files that begin with T. If we say semicolon tilde, this is not the same as Unix. You know, maybe I should change it. But anyway, no file that begins with, how about that? I wonder what this will do. We have no file that has a T. Anyway, it only lets you start with one directory. So this is kind of allows, Unix is kind of perfect or complex. Ours is kind of simplified for beginners. You can only specify one directory. In other words, you can't say semicolon and then another directory. it's kind of a weird. You have a single directory and then you have a file mask, and you can do subdirectories. So this just files actually flattens it to a just a single linked list. Otherwise we would have directory. Anyway, this gets rid of directory entries. And so and then what we did in the optimize is open up the load in each document. We're not going to do that. So how about that?